An important part of our device is the ability to sense seizure through the neural electrode that's connected to the brain. Because what you want to do is be able to take in data from the electrode, determine whether a seizure is happening, and know when to start cooling. And so the algorithm that we have is able to take in the data, change it a little bit in order to determine whether there's a seizure happening or not. We have a metric that we've made called the seizure detection metric, or S. And what that does, the larger that number is, the more likely there's going to be a seizure, or the more likely you detected a seizure. And if you detect a seizure, that means S is greater than a value D that's determined beforehand. So what we have here in this graph is we've inputted 3 types of sinusoids to kind of replicate EEG data. And so the first one has an S1 of 0.01, and so that means it's kind of likely that a seizure might have occurred. And you can see that it has a pretty high frequency while being low magnitude, and that combination means that a seizure may have occurred, but more likely not. S2 has, the second inputted signal has an S of 0, which means that it's not likely at all that a seizure occurred, even though it's very high magnitude. It's because it has very low frequency, and it's a combination of the two that helps us determine whether there's a seizure. And the third one has a lower magnitude but also higher frequency than the second one, and that has an S of 9.96, which is very high, and we're saying in that case a seizure has been detected. And this is how our algorithm works.